go over simplifying radicals. Okay. So we have a radical expression here, and we want to simplify it as best as we can. We're looking for roots that'll eventually be the same. So think of these like they're your variables, right? These are kind of like the coefficients in front of them. And we can collect terms that have the same variables or the same radicals to them. Now, obviously, none of these radicals are the same. We have 32, 50, 12. None of those are similar like terms. But we can split radicals up. If you remember using like factor trees, say I had the number 18, right? If I had root 18. Or root 18, I can think of factors of 18. 1 and 18, yeah, that doesn't do much. I can use 2 and 9. And when I rewrite that, that would be root 2 times root 9. And then what's really nice about that is root 9 is something I can solve. I can get a whole number value or a natural number. It's 3. So this would actually simplify into 3 times root 2. Root 2 doesn't give us anything we can work with. So we want to do the same things with each of these radicals. Okay. So our coefficient will keep the same. We still have the number 3. 32. Can you think of a pair of factors of 32?
2 and 16.
2 and 16. So we'll go with root 2 times root 16. Okay. And that's going to work out really nicely. That's a value. So let's do the same thing again with 50. Can I break 50 up into anything?
5 and 10. Or 2 and 25.
Yes. And that'll work probably much better. And we could have done the 5 and 10 and 2 and 25 is better. Let's do the 5 and 10 just to show you a different way of doing it, because 2 and 5 you're going to end up doing the same way here. Let's say we did root 5. Let's do it in red. Root 5 and root 10. I'll show you how we could still get to it even though we're using nothing that seems to work out really nicely. And then the last one, 12. What can we split 12 into?
2 and 6.
Yeah, 2 and 6. That's right. Okay. That's going to be similar to this one here. Okay, so can we do any simplifying in the very first value here? What's root 16?
4.
4. And then whatever that number is, we're going to multiply it by the coefficient. So 4 times 3 is going to give us 12. So we have 12 root 2. And that root 2 is a prime number. There's nothing we can do with that value. Okay. Now, 5 and 10. Well, 5 is a prime number, and that's kind of like when we're talking about prime factoring using a prime tree. But 10 isn't. I can split 10 again, right? So let's split 10 again. What would we get?
5 and 2.
5 and 2. And that's where it gets interesting. 5 and 2. So now I have a radical times a radical times a radical. Okay? And then I'm going to have to do the same thing over here. I can split 6. What can I split 6 into?
2.
2 times...
Isn't the root... Oh, no.
there's not a root of 6,
No,
yeah. 2 and then 3. And that's going to become important. So even though we didn't pick the correct one right off the bat, like we said, 2 and 25 would have worked out nicely, we can still get to that. We know that we're going to have root 2, and the root of 25 would have been 5. Well, I have root 5 times root 5, and root 5 times root 5 is just the number 5, right? If you're unsure about that idea, think of it like this. If I did root 9 times root 9. Well, instead of just taking that quick shortcut, the root of 9 is 3 times the root of 9 is 3, which is equal to 9. So instead of doing all those steps, I can just write the number 9. So we're going to do that with this number 5 here. We have 12 root 2 plus 5 times, and that would be the number 5. I'll do it in red. So root 5 times root 5 is 5, okay, times root 2. So we're going to multiply those coefficients in a second. And then the same thing is going to happen over here. Root 2 times root 2 is 2, right? And then we'll still have our root 3. I'll put that in red because that's where we actually did some work. Okay. Now I'm doing a lot of extra steps, and you can kind of jump through this much quicker if you want. Let's simplify again. 12 root 2 plus 5 times 5 is 25 root 2, and then minus 2 root 3. Well, now we have some like terms. Our like terms are root 2 and root 2. Root 3, there's nothing we can do. That's the only term. In order to simplify these two, we add the coefficients together because it's addition in front. So 12 and 25 is going to give us 37. So we end up at 37 root 2, subtract 2 root 3, and that is the simplified version of what we had. And I probably should have had equal signs all the way through here, but that is our idea for simplifying.